All right, everybody, here is your review for the quiz. So we have division, we have long division and synthetic division, we have graphing, and we have factoring. So starting with long division, okay, the bigger one here goes into your box, the x minus 2 goes outside the box. All right, so we have to set it up like this. And again, make sure we're looking for any zeros that we need in here, okay? We don't have any placeholders needed right now. So then we divide the front two terms. So we have x to the third over x. We check those out first, and that's how we get our number up top. X to the third over x, that is x squared. That's the number that goes up here. And remember what we do with that. So if you put a number up top, you're going to distribute that through, and that'll get you to what you're subtracting on the bottom. So when I distribute that through, I'll have x to the third minus 2x squared. And I want to subtract those, okay? I'm subtracting whatever I put down there. Okay, those go away. 4x squared plus 2x squared is 6x squared. And now we only have one term down there. We need 2, so let's drop that negative 3x down. And now we're doing exactly the same thing as what we started with, okay? So we're back over here. We're dividing the front two terms. So 6x squared over x is just going to be 6x. That's what goes up top. So plus 6x, take that through. So 6x squared minus 12x, divide or subtract the 2. So change our signs. And then those go away like they're supposed to. Negative 3 and a positive 12 is a 9x. All right, so we only have the 9x down there. So we're dropping the negative 1. And we're doing it one more time. So 9x over x, it gets me a 9. So we're adding a 9 up there, taking the 9 through the binomial there. So 9x minus 18. Switch my signs. And then we have a 17 left down there. So 17 is our remainder. So remember, we always add our remainder. So it's plus 17 over our divisor, which is x minus 2. That is your answer when you divide the two. All right, now we're doing exactly the same thing down below with synthetic division. We should get the same thing, okay? We're just doing two different types of division problem. So let's check this one out down here with synthetic division. So we're doing this divided by this. So this is what tells me the number that I get inside of my box, okay? So I'll set this equal to 0. That tells me I get x equals 2. The 2 is going in the box. So 2 goes in your box off to the side. Draw your line. Look at your numbers here. The coefficients go over here. Okay, and again, make sure you're looking for any placeholders you might need. So the routine with synthetic division, the first one drops down. So we put the 1 down there, and then we're taking it times the 2 that's in our box to get us to here. All right, so that would get me to a 2 there, and then I'm going to add those. So 4 plus 2 is 6, and then I continue the routine. Whatever I have down below my line, that's what's multiplying by the 2 in the box. So 6 times 2 is 12, negative 3 and 12 is a 9, 9 times 2 is an 18, 18 and negative 1 is a 17. So that's my remainder. We started with the cube, we broke it down by an x. So this down here is going to be x squared. So it'll be 1x squared plus 6x plus 9 plus my remainder of a positive 17. So we'll add that 17 over. Remember, this is our divisor, which we can look over here. So 17 over x minus 2, which we get the same thing as what we started with. So that's your division problem. Let's take a look at the polynomials, okay? Graphing polynomials. So is the function even or odd? What we want to look at first. That's going to help us figure out what the graph looks like. So we look at the highest power. That's x to the 4th. So that's going to be an even degree. And specifically, it's a 4th degree polynomial. So we know 4th degree polynomials are going to model parabolas with their end behaviors. Okay, either both going up or both going down. To figure out which one it's going to be, you look at your leading coefficient, which is a positive 1 here. So we know it's going to look like this, okay? It'll be a 4th degree polynomial that looks like a parabola going up, or it has end behaviors going up, okay? We're going to graph this, identify domain and range, maximums and minimums. So remember when we start graphing polynomials, we start with our basic XY chart or table of values. We're going to go from -3 to +3. And I'll show you the work by hand on a few of these, and then I'll put some numbers in there by using my graphing calculator. Remember, you're going to have to show most of your work by hand over here, but you have to use an XY chart. So I'm plugging in a -3 to the 4th power, -3 times -3 to the 3rd power, plus 2, -3 squared. I'm going to run out of space, plus 6. So this will turn into an 81. We do this first, so that's a -27, which is a positive 81. And then that will give me a positive 9 times 2 is 18. And -5 times a -3 is 15. And positive 6. So 81 and 81, that's a 162. Plus an 18 is going to be a 180. Plus a 15 is going to be a 195. Plus a 6 is a 201. I just went from left to right, adding these as I go along, and that's what these dashes are, or the crosses. So the first number is a 201. Okay, that's a pretty big number, so we can't really graph a 201. Let's do our -2 to the 4th power. Okay, we're following the same routine. So -2 to the 4th is going to be a 16. -2 to the 3rd is a -8. Times -3 is a positive 24. -2 squared, that's a 4. Times 2 is 8, so add that 8. This will get me to a positive 10 plus 6. So 16 and 24, that's 40 plus 8, 48. Plus 10 is 58, plus 6 is 64. Okay, so 64 is the next number. Okay, so you're just doing the same routine to get all of the numbers. All right, so -1, we end up with a 17. 0, we get a 6. 1, we get a 1. 2, we get a -4. And then 3, we get a 9. So remember when we're doing these by hand, if you do your generic -3 to +3, you're looking for bigger numbers to tell you where to stop. So I can see obviously here, I am not going to do any more negatives. I'm going to have to do more positives though. So I have to go to a 4 because that 9 is not big enough yet. So if I plug in a 4, I get an 82, and that is an indicator of where I can stop putting in numbers. Okay, then let's graph the function. So really we can't graph these, those are kind of too big. We do know that those are just kind of up here somewhere. So -117, I can kind of put a dot up there as well. So I have 0, 6, which is right here, 1, 1, right there, 2, -4, right there, 3, 9, right here, and then 4, 82 is kind of up there somewhere. So we know our graph is going to start up here, it's going to kind of curve to hit that one, and it's going to go back down to this one, curve up, hit that point, and then we're kind of off where we can't graph anymore. Okay, that's what it's going to look like. So if we check our end behaviors, they're both going up, like we speculated in the beginning. We do need maximums or minimums, okay? So we look for any low points or high points. This one right here is just kind of a curve, so that's not a maximum or minimum. We do have a low point down here, so that's going to be a minimum. So we have a minimum at 2, -4. Okay, that's one of my minimums, and I did want to do domain and range for this up above. Okay, so domain for all these is all real numbers. For 4th power polynomials, range, you're going to be above that bottom point. So y is greater than or equal to -4. Okay, that's how you graph a polynomial. And let's take care of factoring. So looking at my first problem here, I know those are both cubes. So we're going to set that up where we have our binomial and then we have our trinomial. We got the little parentheses and this one's supposed to be the bigger one. So this, we'll take the cube root, you get a 2x. Take the cube root of that, we get a 5y. And then we go to our next set. So this one goes here. So we follow our pattern. It's going to be 4x squared because I'm going to square it to get there. And this one goes here. I'm going to square it to get there. So that's 25y squared. And then in the middle here, we have the two of them being multiplied together. So it'd be 2x times 5y, which is 10xy. And then we remember SOAP. Okay, so same as what I started with, opposite that first one, and always positive in the back. And then you're done. Okay, that's how we do those. Second one over here, they're both perfect squares. All right, so I'm doing difference of squares. So the square root of that's going to be a 2x. Square root of that's going to be a 7. I do 2x minus 7, 2x plus 7. That's how we do difference of squares. And then one more before we're done. Solve the polynomials. So we're going to have to factor this and then solve it to get our zeros. So remember how we do these. If we have x to the fourth and x squared, then that means I'm going to have x squared in the front of both of my parentheses. And then it's just like our reverse FOIL. Two numbers that multiply to 27 and add to a 12. So the first thing that comes to mind is 9 times 3. 9 times 3 is going to multiply to 27. And then we got to see how we can add those together to get to negative 12. They'll both be subtractions. And then to get our final answer, we take both of these binomials and set them equal to 0. So x squared minus 9 equals 0. X squared minus 3 equals 0. Do a little bit of algebra, a little bit of moving stuff around. So let's move that 9 over. Okay, so we'll get x squared equals 9. Square root both of those. We get x equals. Don't forget, we need a plus or minus over there. Square root of 9 is a 3. So those are a couple answers there. Do the same thing over here. X squared equals 3. We just move the 3 over. Square root both sides. We get x equals plus or minus square root of 3. And then those are the 4 answers, right? We get 2 answers from this one, 2 answers from this one. We're looking for 4 answers to have a 4th degree polynomial, okay? So there's your quiz review. Hopefully that helps. Thanks for watching. Good luck.